Okay, good afternoon, everyone. And this is Form 4 Wednesday group. Okay, and today also your first day back to school after, I think, more than 3 months. You are away from school, I think, more than 3 months, right? So I believe most of you enjoy your go back. You feel very happy now, huh? First day back to school, very happy now, huh? So your good spirit must maintain, First day, second day, first week, second week must always maintain lah. Go back to school happily, okay? And maybe you feel a little bit tired first day when you go back to school, right? First week, usually you feel tired because you will need some time to adapt yourself, adapt your time to wake up, okay? Sit in the classroom, cannot go anywhere, right? So you need some time to adapt. So slowly, I'm sure you will feel better in school, huh? Okay? So continue, okay, with your good spirit. I think everyone here, anyone absent from school today or not? Huh? Anyone absent from school? Chan Yuan Yi, you went to school or not this morning? No answer, all this. Yes, you went. Nobody absent. Sima, you went or not? You went to school today, Sima?
Yes, sir, I went.
Good. So very happy at school. Yeah. Susin, what about you? You went to school or not this morning?
Yeah, Teacher, I went to school.
Yeah, okay lah. I can hear it. You are very happy. Go back to school. Okay, come back to our lesson now. Last week, we started this wave, right? Resonant, damping, these kind of things, right? And I believe we started lesson 3, correct now? Reflection. Okay, reflection. Okay. Okay, let's go through this paper quickly so you can have a look what you have learned or not actually. Okay, so I share the paper with you all now. Okay, one moment. Okay, start with this one. Okay, okay, you see this is lesson 2, right? Common terminologies. So you know what is look at here now. Okay, slowly. Okay, amplitude, you see, right? You learn amplitude, periods, and then frequency. All this you have learned, right? What is amplitude? What is periods? What is frequency? Right? After that, you have seen this displacement time graph to find the amplitude, find the period, find the frequency from the graph, right? And also, you have gone through this natural frequency, right? What is a natural frequency? Natural frequency is something like this lah. Something oscillate on its own without any external force. Okay. Usually the pendulum having the same length, when the length are the same, so they will have the same natural frequency. When same natural frequency means it tends to have this to happen, resonant. Okay. Do you all remember what is resonant or not? Remember resonant or not? Pritibha. Okay, Pritibha. Are you there? Hi, Pritibha. Pritibha na. Wainusawan ho. Ziliang. Ziliang, are you there?
Yes, sir.
Ziliang, can you roughly tell me what you know about resonant? Resonant is what actually, Ziliang?
The frequency of force vibration on an object matches the object's natural frequency, and the dramatic increase in amplitude results.
Yes, correct. When a force oscillation have the same frequency, or we say has the natural frequency, same as another frequency, right? So the amplitude of oscillation will increase dramatically. So they experience resonance. Resonance means both pendulum oscillate strongly with the maximum amplitude. Why it happen like that? Because they have the same natural frequency. When same frequency, so they will oscillate very fast with the maximum of amplitude lah. Okay, and also you have gone through few example, right? Good example of resonance, bad example of resonance. Okay, I just roughly want to ask you something now. You all don't scared lah, huh? Susina, are you there, Susin?
Yes, sir.
Susina, can you give 2 example where resonance is good to us? 2 good example of resonance.
Microwave and radio.
Yes, correct. Cooking. We use resonance used in the microwave for cooking, right? And also resonance used in the radio for us to listen to a radio channel. You need resonance. Okay, next one. Hashini, are you there, Hashini?
Yes, sir.
Hashini, can you tell me 2 bad example of resonance? No good one.
Shatter a glass.
To shatter the glass. Okay, what
And
else?
also the Tacoma Narrow Bridge
Yeah,
collapsed
this
due to
bridge, the
resonance.
collapse of the bridge, right, is because of resonance. Okay, you have seen the video, right? Okay, this one, okay, done already. This one, all you learn already, huh? And then after this, you have gone through this damping, correct not? What is damping actually? Damping is what? What is damping? Yutong? Ngu Yutong, Ngu Yutong, are you there?
Yes, sir.
What is damping? Can you tell me what is damping?
A process whereby oscillation die down.
Yes, correct. Due to what?
Due to the loss of energy.
Yes, correct. Okay, it's a process where an oscillation slow down or die down and eventually it stop. Okay, because of the loss of energy. The energy loss, you have 2, one is external damping. That one is because of air resistance, external damping. The other one is internal damping. Internal reason, the molecule of the system lost the energy, right? So it will stop. Okay, and last question. Can you give 2 examples where damping actually can help us? 2 examples where damping helping us. Sima, give 2 examples where damping is good to us.
Shock absorbers in cars.
Yeah, shock absorber in a car. How this shock absorber help us?
When it bump or in the road.
Then the shock absorber will stop the vibration, correct not? Stop the vibration of the car, correct? One more example is what? Sima, look at the screen. One more example is?
Measurement instrument.
In the instrument, the pointer, right? The pointer deflect, then it will oscillate. So prevent the pointer to oscillate. Okay, in the galvanometer, ammeter, wattmeter, we do want the meter to oscillate, right? The pointer. Okay, all right, this one finished already. Okay, after finish this lesson, last week we started with lesson 3. Okay, look at lesson 3 here now. Never mind, we go slowly one by one. Okay, so our lesson 3 was here. We started here, right? Reflection. Do you remember or not? Reflection. Okay. This was what you have learned, reflection, right? Okay. Reflection, you look at this diagram, so you can see very easy to understand, right? when the wave hit a barrier, get reflected, right? You see hit here, then go back. So this is called reflection now. Another diagram is when the reflector is like that, so the water hit the reflector, get reflected. So basically what you learned now was this, to draw this diagram, you draw a normal line, normal 90-degree line to the reflector first. Draw this normal line. And then in the reflection now, there are two angles, angle of incident I and angle of reflection. They must be the same. This angle I, angle reflection, angle R, angle I, angle incident, angle R, reflection must be the same one, When this angle are same, so you come here. Then only you add the line, okay? Okay, by looking at the diagram, I want to ask you lah. During reflection, what has changed and what has not changed? This is important. I told you last week, right? During reflection, what will change and what will not change? What will change and what will not change? Okay, I want to hear from Lau Guan Xuan. Lau Guan Xuan, can you come up, please? Lau Guan Xuan. Guan Xuan,
sir.
Now, you look at the diagram now. In the reflection, right? Okay, what has changed? After reflection, what has changed? Right? You look at your paper to find the answer. What has changed?
Angle of.
What has changed?
Angle.
You don't say angle, Hashini. Lao Neo Mai is okay. Hashini?
Yes, sir.
During reflection, what will change now?
Velocity will change.
Yeah, correct. The velocity will change. And one more thing will change is what? Ngu Yu Tong? Velocity changes. One more thing change is what? Yu Tong?
The direction of the
direction correct. Direction, but you see this one go to the right, then this one go to left, this one go to the right, this one go down. Direction changes, right? So the velocity changes, direction changes. Okay, now my next question what are the things will not change after reflection? What are the things not change one? Never change. So what is that? It seems like you're very tired, your first day go to school. Chan Yuan Yi, Chan Yuan Yi, are you there? Chan Yuan Yi? No sound already. Gong Fan Xin, Gong Fan Xin, are you there?
Yes, sir.
Gong Fan Xin, can you tell me after reflection, what are the things will change? Yeah. The speed and the will not change one. Sorry, what will not change?
Wavelength, frequency, and speed.
Yes, correct. Three things never change. The wavelength, lambda. Second one is the speed, never change. And the third one is the frequency. The frequency also never change. Okay, All right, this one finished lah. Last week we have finished this one. And also we have discussed the experiment, right? Okay. And now we start from here now, okay? Reflections of light, okay. Slowly lah, okay, don't worry. So many of you are first day, even tuition also cannot come. Some message me say too tired, some say too many things to do, homework not finished. So ask me to record the video and upload. I understand first day go back to school, you have so many things to think about, to worry about, correct not? Okay, now reflections of light. Now it's light, Last week you learned these are reflections of water, so now it's light. Okay, I want you to look at this diagram here, this one. So light will be reflected by a piece of mirror. This is a mirror, right? So when the light hit the mirror, so it get reflected. Same law apply. You see, this is incident ray. The one going to the mirror, one called incident ray. This is a normal line. And this is a reflected ray. So you also apply the same law. Angle incident equal to angle reflection. So same thing apply in the water wave, and same thing will also apply in the light wave. Okay, so law of reflection use the same law. Angle incident, angle reflection, same. Okay, but one more thing I remember now. To reflect the light, this surface must have two conditions, you know. I want to hear from you all. Got any suggestion or not? What types of surface will reflect light easily? One. What are the conditions for the surface so that it can reflect the light? So must have what condition? Must have what condition? Then only can reflect the light.
Flat.
Chilling. Just now someone answer. Who? Can you continue? The condition of the surface must be chilling. Okay, chilling, you answer lah. The condition of the surface for reflection must be what? Chilling.
Sir.
Yes.
Smooth.
How chilling?
Smooth.
Yes, correct. Must be smooth. The surface must be very, very smooth. And one more condition is what? It must be hard. Smooth and hard. Must be smooth and hard, you know, to reflect the light. Okay. It must be smooth. If the surface is rough, cannot. Rough, it not reflect. No, it will absorb the light. Okay. So the surface must be smooth, hard. Okay, I remember that. Okay, now, phenomenon reflections of light obey the law of reflection. Okay, please highlight A and B. These are the two laws you learn. The angle incident equal to angle reflection. So angle incident and angle reflection must be the same, right? Okay, and one thing, please make notes. Angle incident I, angle reflection R must take from the normal line. This is normal line. Normal means it's a line 90 degrees to the mirror. That is called normal line. So this angle is angle incident. This one is angle reflection. They must be the same. It's a law already. If law means guarantee correct one, no need argue. Okay. And the second law is what? Highlight. Incident wave. This one incident wave. The reflected wave. This one. And the normal lie in the same plane. It says incident ray, the normal line, and the reflected ray lie on the same plane. What is the meaning of that? What is the meaning of these three lines? It says this incident, this normal, this reflected ray lie on the same plane. Meaning is what? Okay. Meaning is they are on the same surface. For example, like this is a piece of paper. This line, this normal line, and this reflected line, they are on the same page of paper. So same plane, same surface. Okay, All right. This one you all can understand one. Next, it can also be seen that size of the image and the size of the object same. Okay, example, you take a piece of mirror, you stand in front of a mirror, so your cell is an object. Your image will be behind the mirror. This is an image. So you look at your cell now, your sign and the image of your sign must be the same. Same lah. So this is a mirror. So object, image, the sign are the same sign. Okay. Second one, distance of the image same as distance of the object. So you see the distance here same law. The distance from the mirror and this image distance from the mirror same. The distance are the same. Okay, So these two things remember now. Okay. Can understand? Ati, can understand? Huh? Ati Subramaniam. No sound already. Everyone very quiet. Yeah. Okay, next we go through a very simple experiment now for reflection of light. So we see the experiment now. Okay, this diagram. This diagram is to show how the light being reflected. Okay, to see reflection of light, right? You need a piece of white paper. Okay, this is a mirror. To fix a mirror here, you put plasticine. I put plasticine here to fix the mirror. Okay, and then you put protractor here to measure the angle. Okay, after you put this protractor, right, you draw a 90-degree line to the mirror. So this 90-degree line to the ruler, to the mirror, sorry, it becomes the normal line. Normal is here, so you draw this line. And then using a ray box. Ray box meaning that there's a box here. Inside there's a bulb. The bulb send out the light. Okay, our experiment is like this, Control this angle. Let's say you start with this angle 15 degree. Okay, you can this one push up, push down, you can adjust the angle one. So you start with this angle incident 15 degree. Then you see allow the light go, the light reflect. Then you measure the angle reflection. Definitely you will get the same answer. When this angle is 15 degree, you will get the reflection also 15. So it's proven the law of reflection is correct. Okay. Now then, second experiment, you do like this. You push the ray box up a little bit to increase this angle. The angle become bigger. Angle incident now become bigger. Probably 20 degree. Just now 15, now 20. So on the line, and then you notice that the light will be reflected like that. Right? So this angle reflection also become bigger. Okay, so when this one become 20, angle reflection also become 20. So you continue to repeat a few times by adjusting the angle incident. Then you see the result of angle reflections. It's very simple. So your experiment result is like that now, you see. Angle incident start with 15 degree. Then you also notice the angle reflection also same 15. When you increase the angle incident to 20, you notice that the reflection also become 20. And increase further to 25, angle reflection also 25. Same. So you notice when this angle incident getting bigger and bigger, right? Same thing will go to the angle reflection also become bigger. So it's proven that angle incident, angle reflection, same. And when you plot a graph, you get a directly proportional graph like this. Okay? Understand? You Tong, understand or not? You Tong? Okay, okay. I can hear a little bit you Tong. Okay, come. The experiment, we go through the experiment. Okay, slowly, class. Please follow. The experiment to investigate the relation between the angle incident and the angle of reflection. Angle I, angle R relationship. We already know the answer. This angle I and angle R must be the same one. Okay, so your hypothesis is what? The angle of reflection increases as the angle incident increases, meaning that this angle will increase when this angle increase. It's the same Aim keyword is to investigate relationship between angle incident and the angle reflection to see the relationship. Okay, very important is the manipulated variable. Manipulated variable is an angle incident. You control the angle incident 15, 20, 25, like that, right? You control. Then the responding variable will be the angle you measure, the angle reflection, right? And most important is a fixed variable, the constant variable. So remember, is the positions of the mirror. You cannot change it, the position of the mirror. Once you fix it here, this mirror cannot change anymore. The position cannot change. You can only change the ray box, push up, pull down, push up like that. This one cannot change. Okay, it's very important. Fixed variable. And list of apparatus, your ray box, you know like this one, right? Mirror, plasticine, protractor, and white paper. You need a piece of white paper. You put a white paper so that you can see the line clearer, easy to see, and also you can draw. Okay, draw the line. Okay. Okay, procedure. I think I don't want to explain already. You just read through here now. Ray of light directed to the mirror. You direct the light to the mirror. Using protractor, angle incident and angle reflections are measured. Use a protractor to measure the two angles. Okay. And finally, repeat the experiment 5 times for other angle incident. You see 20, 25, 30, 35, 40 degrees. So you repeat. Okay. And finally, plot the graph. So very simple. Reflections of light. Okay. Now I have one question not mentioned in the paper one. I want to ask you all when you do this experiment what is your precaution? What you must be careful about what? What is your precaution? Sima? Please come out, Sima. Sima, what is your precaution here when you do this experiment?
Position of eye. The position of eye.
Position of yes, correct. You are going to measure read the angle, isn't it? So your positions of eye must be accurate. Sima, I'm not finished here, you know. Can you tell me now how you position your eye?
Position the eye perpendicular to the protector.
Your eye position must be perpendicular to the skew of Your eye must be perpendicular to the skew of this protractor, correct? Not to avoid parallax error. You can jot it down. Precaution. Avoid parallax error by position the eyes perpendicularly to the skew of protractor. Okay, your eye must be 90 degrees. Okay, that one will be your precaution. Okay, all right. So this one finished. Okay, next one, last one will be sound. So in this chapter, you learn water wave. After that, light wave. After that, sound wave. After that, you can learn 3. You know, water, light, light. We have just done. Now sound. Sound very simple, Sound also can be reflected. Okay, you see a piece of wall can reflect the sound, right? Rock, mountain can reflect the sound. Okay, so you look at this diagram. How to do reflection of sound? Okay, you need a smooth wall. This wall must be smooth, must be hard. Okay, then using a stopwatch to produce a light, tick, 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 tick. Okay, and the sound sent through a tube. Okay, so the sound travel through the tube, hit the wall, get reflected. Then you put your ear here to listen. You can listen the sound. So the sound comes from the stopwatch, reflected, go into your ear so you can hear the sound. Okay, my question here, why in between here you need to put a piece of softwood here? Why? Why need to put a piece of softwood? Why? Why need to put a piece of softwood there? Kong Fan Sin, are you there?
Yes, sir.
Konga, why need to put a piece of wood here? Why?
To be the perpendicular line.
To be the perpendicular. Why not you just draw a line only? We have other function of the softwood, you know. Okay. Besides being the perpendicular line, right? The softwood actually can prevent the sound because actually sound can go any direction one. It doesn't mean that you put a tube here, the sound will go through the tube, you know. Sound can go here, can go here. Any direction, the sound also can go one. Understand? Sound never listen to you one. It will follow any direction. So we don't want the sound to travel direct to the ears. Like that, we don't want. We don't want this to happen. So they say, if this one can happen means your result will not be accurate already. No, what you hear can be the sound go direct, not accurate. So to prevent this thing from happening, you put something here to block the sound. Okay, that's the reason. We want the sound travel here, reflect. So what you hear was the sound actually come from here, reflect. So that is the purpose to have softwood, you know, to prevent sound travel direct to the ears, okay, without any reflection, okay. Now, experiment same law. You can see here, angle incident, angle reflection, same. So the experiment also carry out like this. First, you put here 15 degree. So you get this result also 15. Second, make this angle bigger and you can put this stopwatch put here and then the angle become 20. So you get this result also getting bigger 20 and so on lah. Like just now, lor. So you see the result is like that. Okay. Yeah, so you get the result like this, lor. Like just now lah. Angle incident 15, reflection 15. Increase to 20, you also get 20. Same lah. Okay. So when you see angle incident getting bigger, angle reflection also getting bigger. So it's a directly proportional graph now. So the result is like that. So this experiment carry out to show the reflections of sound wave. Okay, come we go through it quickly. Yeah. Hypothesis, angle reflection increases as angle incident increases. This one getting bigger, this one also getting bigger. And investigate the relationship between angle incident, angle reflection. Okay. And manipulated variable, same angle I. Responding, same angle R. And now fixed variable a little bit different. Fixed variable is the position of the stopwatch from the smooth wall. Position of the stopwatch from the smooth wall. I don't think this is correct, you know. Can we fix the position of the stopwatch? You need to adjust right, to increase the angle, correct not? So this one cannot fix here, you have to move around. And then if because of that, then what must be fixed? If not the position of the stopwatch, what must be fixed? Can anyone tell me? Hashini? Hashini,
Sir. Position
Hashini.
of softwood.
Oh, you mean this stopwatch position? Yes, correct. This stopwatch cannot be fixed because we are going to move to make the angle bigger, right? Then this softwood, the position must be the same. Yes, correct. Okay, so this one you change that. Fixed variable is position of softwood, not the stopwatch. The stopwatch actually need to move around. Okay. Yeah. Next, apparatus, yeah, cardboard tube, softwood, stopwatch, protractor to measure angle and smooth wall. Okay, must be smooth. Okay, All right, now procedure very fast. Using protractor, angle incident measure to 15 degree. You start with 15 degree. Just now we say, right? Start with 15 degree. Okay. Okay. This is 15. Then turns on the stopwatch. Then cardboard B move around until watch can be heard more clearly. You move the board so that your ear can hear the sound very, very clear. And then you measure the angle R. So repeat five times with different angle incident, not 20, 25, 30, 35, 40, same like just now lah. So that finish up this lesson, okay? So finish already. Now we answer the question. Have you answered any of the question? Have you answered any question? Susin, have you answered any question? Last week?
No, I don't think so.
Okay. Okay, good. Okay, now we answer the question. Okay. First question. You study the question you all. Which figures show the correct patterns of reflections of water wave? You see A, B, C, D. Which diagram show reflections of water correctly? Think, go and find the answer now. Okay. Susin, come on. Can you give the answer? Try. Number one, which one is the answer? Ask Susin. I think
D.
Yes, correct. D is correct. Very good. Okay. Because we know that the wavelength lambda must be the same one, like this one wrong already. This one lambda so big, you see the gap a big lambda wavelength. Then this one gap lambda here becomes small. This is wrong. Lambda shouldn't change one. Okay, and this is definitely wrong. This is not reflection. Okay, this one also not reflection. Okay, reflect means it should be come back one. It should be come back like this. Okay, so the answer donkey. Okay, number two. Because show a set of plane wave arriving at a plane reflector in a ripple tank. Okay. Now, the question is like that. The diagram is like this, okay? Hit the reflector, they come back reflected, right? So which of the following will change? They ask you, which one will change? Which one will change then? Sima, which one will change?
C.
Again, Sima?
C.
C. Okay lah, correct lah. The direction, wave direction C, okay? Direction very obvious go to the right, this one go to left, correct not? Okay, question 3. Diagram shows a single ray of light being directed at the mirror. The mirror, you see the diagram, I do want to show the answer first. Now the question, what are the angle incident and the angle reflection? I believe some of you sure make mistake one, by looking at the diagram, how to find angle incident and how to find angle reflection. Try, okay, try first. Later when I call your name and you give me the answer. So what is the angle incident? What is the angle reflection? Okay, do now, okay? Yeah. Yutong, Yutong, can you come out? Yutong? Yutong, can you tell me what is the answer? Try now. What is the answer?
D.
Donkey, C or donkey?
Donkey.
Okay, donkey. She said donkey. No, now you see. So what is the answer? Yutong is here. This time I say correct one. Sure, some students will make mistake one. Okay. The angle incident and reflection must draw a normal line. Draw a 90-degree line. The normal line must be to the mirror one, 90 degree. Then the angle incident must take from the normal line to the incident ray. So it's 35. Here 55, so here must be 35 lah. So this angle I 35. Angle R also must take from the normal line. So also 35. Okay, you don't understand? I know some of you say these are 55, here also 55. No, cannot. The angle must take from the normal line one. This is a normal, okay? Normal line. Okay, everybody understand, Okay. Number 4. Diagram show a mirror tilted at angle 50 degree. Bend, Ray of light directed so that it hit the mirror at angle 20. Now, at angle 20 degree, you see the diagram, Now they ask you the question you all know, Can you see the question? What the question are? Why the answer 70? What is the angle of reflection? Why the answer is donkey? Where to get 70? Now I ask you to explain where to get 70 degree. Hashini, why the answer 70?
Wait, sir.
Okay, I wait for you, Hashini.
Because the 20 degree we plus with 50 on the normal line, then get 70 also, the reflection.
Like that, Okay, what about Hima?
90 minus 20.
Again?
90 minus 20.
Yes. Hima, you are very, very smart. 90 minus 20. You see? When you draw a normal line, right? The angle here must be 90, total must be 90. Okay? Here 90 lah. So here 20, here must be 70. Remember, the angle incident must take from the normal line. Normal measure here 70. So reflection also the same, 70. So light hit here, reflected here. So this angle 70 lah. Incident 70, reflection or reflected angle also 70. Okay. This kind of question sure will come out in the exam. Angle incident, you must know how to take, Okay, number 5. Figure show 2 mirror JK, LM placed at right angle, mean 90 degrees to each other. Yeah. When you look at the diagrams, can you tell me how the light continue to move? Which diagram is correct? The 2 pieces of mirror is here. One is here. One is here. So when the light hit this mirror, then how the light continue to go? So which diagram gives the correct answer? Okay, think of it now. Everyone think, Those who join the class tonight, you are the best. You are very strong. The rest are very weak, First day, school start, night time very tired already. So cannot come, cannot attend tuition. You're very strong, so it's very good. Okay, you all. All right, now let's hear what is the answer. Okay, I call Zhong Zhaoyi. Zhong Zhaoyi. Zhong Zhaoyi, I know you cannot talk. Never mind. Can you type it out? Which one is the answer? A, B, C, D. Zhong Zhaoyi. Zhaoyi, please answer. Dong Chao Yi, are you there now? Okay. See what one answer now. Dong Chao Yi say the answer B, boy. Okay, let's check Dong Chao Yi answer correct or not. Yes, correct. The answer boy. Okay, well done, Dong Chao Yi. The answer is boy lah. Okay, the light hit here, reflect again. So the answer B is correct. Okay, huh? Next question. Echo is caused by what? Echo is caused by what? Now I want to call another one to answer. Jin Yi Hong. Jin Yi Hong, can you come out? Wow, Jin Yi Hong. Echo is a phenomenon caused by what? Jin Yi Hong. If you cannot speak, cannot talk, never mind, you type the answer. Jin Yi Hong. Jin Yi Hong, I'm waiting for you. No. Jin Yi Hong, what answer? Okay, he typed. See what he typed, He said vibration. Echo is caused by Jin Yi Hong, you know what is echo or not? Okay, echo is another words, same meaning with reflection. Reflection. So the answer is reflection. Okay. Echo and reflection, same one, you know. Remember that, Jin Yi Hong, remember? No. Echo 就是回音回音 reflection Okay. Echo, same meaning, caused by reflection. So remember that, Number 7. Figure show a sound reflect from a wall. Okay, the sound hit the wall, get reflected. Now the question, compare with the incident wave. This is incident, this is reflected wave. Okay, now they ask you, which one is the answer? Comparing the incident with the reflected wave. So which one is the answer? Ati Supermaniam. Ati, can you answer, Ati?
Is it D, the same velocity?
Nah, same speed, not velocity. Okay, the speed same, you know, but not the velocity. Can someone tell me why? The speed are the same, but not the velocity. Susin, can you tell me why?
Because velocity have direction.
Yes, very good. Susin are very smart. Right. Like these are the direction different, so you cannot say velocity same law because the direction also different, right? Because our velocity has direction one, vector quantity. When the direction not the same, so meaning that the velocity not the same. Whereas speed has no direction. So different direction doesn't matter. As long as the speed same, then can already. Okay. So speed same, remember, Okay, number 7 done. Now number 8. Okay, now you look at the question, study the question carefully. Study first, Figure show plain water wave produced by vibrating wooden bar at the rate of 15 waves per second. When you see the word 15 waves per second, anything per second means a frequency. So the frequency is 15 hertz. Because 15 waves in 1 second, so the frequency is 15 hertz. Okay, Now, mark the figure, mark the direction of propagation of the wave. Okay, draw a line. So you draw a line, put arrow to show the direction of the wave, which is traveling from left to the right. So make sure here is 90 degree, and draw the line. Done, huh? Next question. Determine the wavelength. This one I don't want to say anything. Can you tell me how to find the wavelength lambda? How to do it? How to find the wavelength lambda? How to find wavelength lambda from the diagram? You calculate or you do something else? How to find the wavelength lambda? Okay. Lim Yu Xuan. I know you are there. Lim Yu Xuan, please come up, please. Can or not, Lim Yu Xuan? Lim Yu Xuan, how to find the wavelength lambda from the diagram?
Yes.
How to find the wavelength?
F equal to lambda 8.
V equal to F lambda.
F lambda.
And the formula is correct lah. You mentioned the formula is correct. V equal to F lambda. But can you use a formula to calculate V equal to? The formula he mentioned is correct, you know. V, the speed, equal to frequency multiply the wavelength lambda, this formula to find the lambda. But yeah, are you given the speed? No speed, but then how to find? You have the frequency now, 15, but no speed. Then I cannot find the lambda. So how? How to find it? Okay, I want to hear from another one. Never mind, you don't worry now. If you don't know, your answer is not correct, don't be shy. So it's very common, okay? Ziliang, Lim Ziliang?
Yes, sir.
Ziliang, now, we cannot use this formula to find wavelength. Then how to find the wavelength?
Sir, I have no idea.
Okay, now mine. Okay, but thank you for your response. Okay, next, Yu Tong. I want to hear from you. Yu Tong. Yu Tong, Yu Tong, are you there?
Yes, sir.
Yu Tong, since cannot use this formula to find wavelength lambda lah, then how to find the wavelength lambda? Any idea?
Don't know.
Don't know. Okay, never mind. Let me try. Hashini.
Don't know, sir.
Don't know. Okay. Sima, you know or not, Sima?
6, sir.
How, Sima?
6, sir.
How you get the answer, Sima? How you get the answer, Sima?
The gap is 1. Every wavelength.
No, how you get the answer? How you get the answer?
I calculate from the diagram.
Oh, you calculate lah. Wow.
No, see from the diagram.
Okay, I try one more person. Last person. See who. Susin. Okay, Susin. How to get the lambda? Susin.
Yeah, sir.
How to get the lambda? Sin cannot calculate. So how to get the wavelength lambda?
How many times the line pass through the middle line?
Oh, like that one. No, not like that. Okay. Actually, you all think too much already. You cannot calculate. You just take a ruler, measure. Take a ruler, you measure here. This is a lambda one. So just take a ruler, measure the distance here. This is a wavelength lambda. So use a ruler to measure. So what is the answer? And now you measure. Everyone measure. What is the answer? Hashini, tell me.
Sir, I don't have the paper with me. I use phone.
You do paper lah. Okay lah. Yu Tong, you have the paper. Can you measure? Yu Tong. What is the value of
0.6.
Good, correct. 0.6. Just measure only 0.6. Okay, measure here. You measure here. Here all same month. 0.6. Okay. So this one done. Next one, calculate the speed. Now you calculate. Calculate straight away lah. Use this formula. Find the speed. Put the frequency. Multiply the wavelength lambda. You get the answer. 9 cm per second. Because this one is in cm, so your answer is cm per second lah. Okay. Okay. Okay, next one. A plane reflector placed at different inclined angle in front of the waterway. Okay, this one they ask you to draw lah. Okay, I think you can just see lah. Please copy the answer lah. This one hit the wall, reflected. So make sure now you draw the direction, the line, incident, reflected. Make sure this one 90 degree now. And the wavelength lambda must be the same. This lambda and this reflected one, the lambda also must be the same. Okay, you see, this one and this one same, lambda. And this one also same. Draw this line, draw the normal line, normal to the reflector. Always remember this one 90 degrees, so this is the normal. So angle incident equal to angle reflection. These two angles must be the same. So it hit the reflector, reflected to this direction. Then only you add the water wave, add the line, and make sure this wavelength lambda and this lambda same. Okay. Okay, please copy all the answer. So they want no paper one, or they want just a screenshot. I don't have any way to give you the paper lah. You have to print yourself or print out yourself. Okay, finish or not? Yeah, finish, Sima, finish or not?
Finish.
Finish, okay. Dong Chao Yi, finish or not? Okay, finish, Okay, come. Okay, come. So we have finished our lesson 3. Okay, finished already. So you see in this chapter, you start with the fundamentals of wave, lesson 1. Lesson 2 is resonance and damping, also finished. Lesson 3, reflection. So we have just done it, reflection. So 3 lessons already. So now we are going to start lesson 4. Okay. Before I start lesson 4, lesson 4 will be very difficult, a bit complicated. Okay. A lot of drawing you need to do. Okay. So you must have a paper, because later on you will need to learn, practice to draw diagram to show the refraction. Okay, lesson 4. So I hope everyone, if you didn't print the paper, doesn't matter. You use a foolscap paper. Certain diagram I want you to practice, so you just use a foolscap paper, draw. Drawing is very important, Next lesson. Okay, come. Let's see the lesson. When you look at the paper also, you get a shock, a lot of drawing on, Yeah. Okay, your title, right? Lesson 4 is refractions of wave. Refraction. This one is FRAC. Your previous lesson was reflection, FLEC. Different, This one is FRAC, refraction. Okay. I want to let you know what is the meaning of refraction first. You see this diagram, this one. So this is A. This one is water. So there are 2 layers here. A, this one is water. We know that water is denser. A is less dense. It's less than A. So when you see the light moving from the A into the water, you can notice that the light bend, when moving from the light go into water, you can see the light got bent. So the bending of the light, when it moves through different medium, so we call it refraction. Another meanings are refraction means change in direction. When the direction of propagation change already, so it's called refraction. Okay, change in the direction. Change in direction with the condition the light moving through different medium. This one A to water, so it will change direction. It will bend. This kind of bendings of light when move from different medium, right? This is called refraction. Okay, now I want to explain to you why this happened. You need to have a lot of listening here. Listen carefully. In the air, the light will move faster. When go into water, the light moves slower. It moves slower one because light is less molecule. So the light can travel faster because the molecule to block the light is less, so you can travel faster. When go into water, right, water molecule denser, so closer, so it will block the light, so the light moves slower. When change in the speed happen, right, here fast, then suddenly slow, change in the speed. When change in the speed, it will change direction, it will bend, it will refract. Understand? So remember, refraction is due to change in the speed of the wave, When the speed changes, for example, like fast to slow, so it will refract. Okay? This refraction is towards the normal. This is a normal line. Draw a 90-degree line to the water surface. The light move and then bend towards the normal. From less than to denser, it goes towards the normal. Bend towards the normal. This is a normal line. Wait, this one also you remember, From less than to denser, like it bend towards the normal. It refract towards the normal. Okay. The other way around also terbalik lah. From denser, it can go. Okay, for example, like denser go to less than, it will blend, it will refract away from the normal. Okay. So okay, so this is light, refractions of light. Okay. Next one I will show you is refractions of water. Okay. Water is here. I want you to look at here. Don't skip first, slowly now, This is water, Okay. The water move from deep water. This is deep. The water is deep. Here the water becomes shallow because you put something inside the water to make the water shallower. Okay. So when water moving from deep to shallow, right? So the water will move from fast to become slow. So when change in the speed happen, so it will change direction, it will bend, it will refract. So the refractions of water wave is happening when the water moving from deep to shallow, or from shallow go to deep. Okay, I repeat again. Refraction of light is because when the light move from different medium density, one medium to next medium, then one light will refract. Whereas for water, refraction of water will happen when the water move from different depth. For example, from deep to shallow, or from shallow water to deep water. Then the water wave will refract, will change direction. Okay, understand? Okay, there is another thing I want to tell you. Look at this diagram. The wavelength lambda. In the deep water, the wavelength lambda is big. When you go to shallow, the wavelength lambda becomes small. You notice or not? Here the line very get big, right? Lambda is big. When you go to shallower region, the wavelength lambda becomes smaller one. Remember, something to remember, And also one more thing, in the deep water, the water go faster, the speed faster. When you go to shallow, it becomes slower. Also memorize. Lambda big is faster in the deep region. In the shallow water, lambda small and then it's slow. Okay? Whereas in the light, less than medium, it go faster. When it go inside water denser, it becomes slower. Okay? Yeah? Think it over now. This is only the starting of this lesson, no? A lot of new thing for you all, okay? Can you Tong can follow or not? You Tong?
Can, sir.
Can. Chiu Ling, can you follow? Chiu Ling?
Can, sir.
Can, Okay, then we see the definitions of sorry. Yeah. Now look at here. Yeah. Here a lot of things here. No, you have to see. Follow what I say. Refractions of wave. Refraction occur when wave highlight move from one medium to another, which causes to travel at different speed. I told you just now. When the wave experiencing change in the speed, so refraction can happen. It will change direction, because change in the speed. Yeah. Okay, next. The refraction occurs when the water wave move from deeper water to shallower water. I told you just now. Refraction can happen in the water wave when water move from deep water to shallow, or the ballet shallow to deep also can. Then light to have refraction must move from A to water. I show you here, A to water, right? And a sound wave also can refract when, sound is moved from A into carbon dioxide gas. Okay, why then? because A is less than carbon dioxide gas is denser. So meaning that refraction of sound when the sound moves through medium with different density. A less than carbon dioxide denser, so the sound will bend now. Later on you will study, okay? So now you know a little bit first. Now, most important is here. When the refractions happen, the frequency F does not change. It won't change one. Only the frequency never change. Okay? But wavelength lambda, the speed, the direction, all will change. So please highlight carefully. Under refractions, only the frequency never change. Okay? Whereas the wavelength lambda will change. You see here? Just now I show you the lambda. No, you see here, this lambda big, this lambda small, the lambda change, correct not? Yeah. The speed also change. Now, you see fast and slow, the speed change also. And the direction change now, of course, because it bend, isn't it? Bend, so the direction will change. Right? Okay. Now, please memorize the whole paragraph, okay? Take some time. Later, I ask question. Please memorize the whole thing here now, okay? Start from now. Yeah, done or not? Okay, come. Start with this one. Pritiba. Pritiba, are you there? Pritiba, can you come up, please? Pritiba. These are all missing in action. Pritiba, where are you? Kong Fan Sin. Kong Fan Sin.
Yes,
Fan
sir.
Sin Kong Fan Sin. Okay, come. Your question very simple one, don't worry. Refractions of wave the wave bend, isn't it? Refracted means bend now. Actually, what caused this refraction to happen? What is the reason of refraction to happen?
When the wave moves from one medium to another, which causes to travel at different speed.
Yes, correct. Very good answer. When the wave experiencing change in the speed, so refraction can happen. Okay, remember that. Pritiba, now my Pritiba, and your microphone was up, right? Now my, can you type? You type. Now Pritiba, get ready. You type your answer. Yeah, Pritiba. My question is like this now. How to make this water wave to refract? Water wave will refract in what condition? Can you answer, Pritiba? In what condition the water wave will be refracted? Type the answer now, Pritiba. Under what condition water wave will be refracted? Okay, I see your answer now. See what she typed there. I'm not sure. So your answer is I'm not sure, Prithipa. Not sure, never mind. You tell me what you're not sure. Can you type or not? You look at the screen now, Prithipa. The answer is already on the screen. Okay. Chong Chao Yi, can you answer or not? Chong Chao Yi? Under what condition water wave will refract? Chong Chao Yi? Chiu Ling. Okay, Chiu Ling. Come, Chiu Ling. When the water
wave
again, Chiu Ling,
move
move from
deeper water to shallower water.
yes, very good. Thank you, Chiu Ling. That is the answer lah. Water will refract when move from different depth deep water to shallow water. Or the ballet from shallow water go to deep water. Okay, that one done. Next question. When the someone type, I see what is from deep water to shallow water. Yes, correct. Chao Yi, your answer is correct also. Chong Chao Yi, correct. Okay, thank you. Next question is under what condition the light will refract? Now it's light. When the light ray will refract. Okay. Now Hashini, please. Now is your turn, Hashini. Under what condition? Yes.
Cannot hear your question. Can you repeat?
Okay. I say when the light will refract, the light.
Move from air to water.
Yes, very good. Move from air to water, different density. Then Hashini, just now you say move from air to water, it will refract, right? The light. What about when the light move from water to air, can or not?
Can.
Can. Also will refract, man. Understand now? Okay, thank you. Okay. One more question. In what condition the sound wave can refract? Sound wave. When the sound wave can refract, Lim Yu Xuan. Okay, Lim Yu Xuan, can you come out? Lim Yu Xuan. Lim Yu Xuan okay, can you tell me when the sound wave will refract? Sound. You look at the answer, look at the screen. When sound
the water move from deeper
sound,
water.
Sound, not water. Sound. 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 When the sound wave will refract, the sound move from where to where? Look at the screen.
From
where to where now? No, just you look at your screen. The screen there got
from air to water.
Yes, correct. Correct. Thank you. When the sound move from air to water or from water to air. Okay, thank you. And one more. During refraction, right? What will not change? What will not change during refraction? What will not change? Okay, now this Ziliang. Lim Ziliang.
Yes, sir.
Okay. After refraction, what will not change?
The frequency.
Yes, correct. And then what will change? Can you tell me, Lim Ziliang?
Wavelength lambda and the speed and the direction of propagation.
Yes, correct. Very good answer. Okay. Frequency will never change. Then the wavelength, speed, direction, all will change. Okay. Okay. So now we move on. Okay. Now we start with refractions of water. water wave. Okay, as I told you earlier, water, just now we say from deep water to shallow water, right? Water will reflect, isn't it? Deep to shallow. But in the school lab, how to do the experiment to show the reflection, how to show deep water, how to show shallow water in the school lab, in the science lab. How to have deep water, how to have shallow water. Okay, you do like this. See carefully here. You look at here. This is a river tank. You put water on the river tank. So you put a piece of plastic or glass inside the water. So you notice this part of the water becomes shallow. This part of the water is deep. That is how you produce deep water and shallow water, Here the water deep, so you put something inside the water, put plastic glass under the water, right? So this water will become shallow. Understand? So remember, wait, this one also SVM asked before one, how to produce deep water, how to produce shallow water. You put glass or plastic put inside the water. Here becomes shallow. Okay, now you see the diagram. See this table. Shallow water to deep water. I can say shallow to deep. Okay. In the shallow water, right, the speed decreases, meaning that in shallow water here, the speed smaller, decrease. Lambda also decrease, and the frequency constant, never change. So remember, in shallow water, the speed small, lambda also small. Frequency constant. Okay, whereas you go to deep water, the frequency, the velocity, speed increases. Lambda also increases, but the frequency remains the same. So remember, in shallow water, speed decrease, lambda decrease, frequency constant. In the deep water, speed will increase, lambda increase, frequency constant. Okay, come, 1 minute, memorize. Memorize it, please. Okay, time's up. 1 minute, very fast one. Okay, now. Lao Yixin. Lao Yixin, can you come up? Lao Yixin? Lao Yixin, are you there? Okay, yes, Lao Yixin, you answer my question. In the deep water, what happened to the speed? In the deep water, what happened to the speed? Yes, the speed increases, correct. What about the frequency in the deep water? Constant. Okay, one more. What happened to the lambda? Also increase. Yes, correct. Yeah, Yixin, correct. Thank you. Okay, next question. Chiu Ling. Chiu Ling. Ling, please.
Yes, sir.
Come on. Chiu Ling, can you tell me now? In the shallow water, what happened to the speed? What happened to the lambda? What happened to the frequency? One short answer all. Chiu Ling.
Speed decrease, wavelength decrease, and frequency constant.
Yes, correct. Very good. Okay, remember all this all. Now you can remember, Then next time I see you, I ask again, cannot remember already. Everyone, you have to find a way to memorize. Okay, somebody tell you, study, no need memorize one. The fellow is talking bullshit, I tell you. You don't memorize, how you going to learn? How are you going to score in your exam? You have to memorize. A lot of these modern people and modern techniques of teaching say no need memorize one, They want all bullshit one, don't believe. You still need to memorize one. Okay? Yeah. The next, drawing. First diagram, I show you how to draw. Now start to draw already. A lot of drawing you do lah. Okay. First one. Here is deep water. Here it becomes shallow because you put a piece of glass inside the water to make the water shallow. So you see, from deep water, when this angle you go in 90 degrees, right? It's a 90 degree, go in perpendicularly. So the wave will not bend, will not change direction. When it go in 90 degree, it won't bend one, I tell you, no refraction one. But the lambda becomes smaller, you see? Here deep, when go to shallow, the lambda becomes smaller. So you draw the line closer, the lambda becomes smaller. And here, fast, goes here, shallow, becomes slow. So the lambda small. And when it come out, back to normal. The lambda become same as the original. And still move in a straight line, okay. The point here I want to say is one, when the wave propagating right angle to the medium, so it wouldn't bend one, it goes straight. So meaning that in the case when the wave move 90 degree go inside, no refraction happen, no bending. But the only thing will change is the lambda and the speed. Lambda getting smaller, speed getting smaller in the shallow region. Okay, draw the diagram. This lambda bigger than this lambda. Okay, draw it now. Besides, I say you don't have the paper, at least you must have a foolscap paper. You practice how to draw. You must practice, don't get a screenshot, then you think you know already. No, you have to practice. Use a foolscap paper. Yeah, finish, Okay, come. This one I think very easy lah. Next diagram will be more complicated. You don't do first, listen. I explain to you first, okay? Come, listen. Listen, everyone listen. Now, the water wave no more going in 90 degree already because this piece of glass is different. It's like that. So this one shallow, this one deep. Okay, what you need to draw is like this, remember. Draw a normal line. Normal to the surface of the glass. 90 degree. Draw this line first. Okay. And water move from deep to shallow, right? It bend towards the normal. It bend down to the normal. The normal is here, so you bend down to the normal, bend near to the normal, bend towards the normal. That's why you bend down. Because the normal is here, so you go down to the normal, bend down. Okay, meaning that the wave move and then bend. Then when go out from shallow to deep, same thing. Draw the normal, the blue color line. Normal to this surface 90 degree line, so this is normal. Okay, from shallow to deep, right? It bend away from the normal, you see? Refract away from the normal. Here, refract towards normal. Here is away from normal. Okay, you see now? This is the normal. Away from normal mean also go away from the normal, mean go down also lah. Because the normal is here, Away from normal means go down. Here, because the normal is here, so towards the normal is go down also. Down means go towards the normal. From deep to shallow, reflect towards normal. From shallow to deep, reflect away from the normal. So you must make sure you understand towards normal. This one is away from normal is also down because normal is here, away means go down. This one normal is here, towards normal is go down. Okay, huh? Once you already identify the direction of this line and this line, right? Then only you add this line, add the wave. Okay, you draw the line so that the lambda here becomes smaller. Shallow, the lambda should be small. And all this line, make sure 90 degrees. So draw all the line like that. 90 degrees, huh? And then after that, you know the direction go out already. And then only you add this line, add the line, 90 degree, 90 degree, all 90, huh? And make sure this lambda, same as this lambda. Only the lambda here becomes small. And drop down here, deep to shallow, refracted towards the normal. Normal is here. So go towards the normal, near to the normal. From shallow, go up to deep, away from the normal, refracted away from. But because the normal is here, away from normal means have to go down, away from the normal. Okay. Now please copy the diagram. Okay, done or not? Yeah, we have a few more diagrams to go now. Okay, so we move on to the next one. Don't worry if you not finish the diagram because the video I will upload to the YouTube. Later on, you can see the video to draw the diagram. Okay. All right, next one. C. C, shallow is here. So this one go in perpendicularly 90 degrees, so no bending, no refract. So the line goes straight. So you draw this straight. After that, just draw the line with the smaller lambda. That's it. The lambda becomes smaller. Lambda here big, here lambda small. But when it go out, then go out, it will bend. You draw this normal line, 90 degree normal line. So as I told you earlier, shallow to deep, it bend away from the normal. Normal is here. Away from normal means must go down. Away from the normal. Okay, it bend down lah. After you identify the line already, any angle also okay lah, as long as it go down, understand? Then only you add the line, add the wave lah. Here make sure you join, this one must join one, join with this one. So meaning that you bend or bend, okay? Then this lambda, same as this lambda, only here the lambda small. Okay, please copy the diagram now. Yeah, finish. If you Xuan finish or not?
Finish.
Finish, huh? Okay, Hashini finish. Hashini no. Yuling finish.
Finish, sir.
Okay, okay, come. Now we move to the next diagram, T. The next one, this is a triangle shape, you know, the shallow is triangle shape, so a lot of bending here. First, straight, draw this normal line, normal to this surface, 90 degree to this surface, so draw this normal. Then you must know, from deep to shallow, bend down, bend towards the normal, and then towards this normal, go near to the normal. So you bend down. Then after that, for this surface, this is a normal. Draw this normal. 90 degree to here. Then shallow to deep, it bend down again, bend away from the normal. This is a normal, away from normal, so it come down. Here, this is a normal, towards normal, so it go to the normal. Here, normal is here, shallow to deep, away from normal is also down. After that, you know the direction already, bend here, bend there, and then you draw the line. Finally, only you draw all this line, the 90 degree line like that. So this lambda, same as this lambda. And then make sure here is join, you know, you join up. Okay, and here the lambda becomes smaller. Inside the shallow region, lambda smaller. Okay, okay, please draw now. You don't finish or not?
Finish, sir.
Finish, Chào Ý, chồng Chào Ý, finish or not? Okay, finish, Chào Ý. Okay, come, we move on to the next one. Next one, this is curved surface. You see, this one curved shape one, curve here, and here also curve. Okay, when the surface is curved, right? So you go straight, but it will follow the first surface. This surface is curved like that. So all the wave go in will curve, follow this surface, all curve. The lambda becomes smaller. You see the lambda small, here the lambda big. Here lambda becomes smaller, but it curve, follow this surface. But when it come out, it's different already, you know. Shallow to deep. Shallow to deep, it will continue the shape, but the lambda become bigger. You know why, you know? Because I want to take this example, this line. So here is shallow, it's move slow. Then here, because it's deep, so it will go fast. Go fast means you go forward. This one all go fast, go forward. This side will bend out. because this one go faster, deep region it go faster. Here slow, 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 slow. This one go faster. So all will pan out, all pan out like that lah. This one also go faster. Then the lambda back to normal. But when it go out, it curve out like that, right? Then it will finally focus at the focal point. This is a focus point. It will focus to this point. And then start from this point, it will go out again. Now change the direction, the curve. Okay? Just now curve in, now curve another direction. So the lambda, same as this, same as here, the lambda. Only here the lambda becomes smaller. So remember, if you follow this shape, the curve, then here the lambda back normal curve becomes smaller, smaller, smaller. Then it go out again. Okay? All right. So this is a focal point. Okay? All right. So the arrow showing the direction now. The wave focus here, and then start from this point. It go out. The arrow must draw. Now, Lau Quan Xuan, finish or not?
Yes, finish already.
Finish, Susin, finish or not?
Yeah, just finish.
Okay, come. One more last diagram. Last, one more. Also curved surface. Okay, now the curve is different direction already. Curve like that. Okay, so what happened is here, go straight, go inside, then follow this curve. So you draw the line, follow this curve, and make sure the lambda here wavelength becomes smaller. And when it go out, it will still follow this shape one, but it will go further. It bend outside. Why bend outside? Because here it move faster. Here when move faster, so it will go out. Here move slow. So this, when it will only bend outside when it go to the deep region, so it go faster, then it bend forward now. So the bend become bigger, the angle bending become bigger. Okay, so it bend and then finally it go back to the normal. It becomes straight line back to normal lah. So the curve is here, the lambda smaller, then it curve out, getting bigger, lesser, then finally becomes straight line. And when you draw the line, to show the direction, the wave is going out, here going straight, here going out. But when you extend the line, you notice that the line focus at a point. So meaning that the wave here actually come from this point, Okay, it come from this focal point. The focal point is behind. Okay, so you draw the diagram. Okay, finish the diagram. Sima, finish or not?
Finish, sir.
Finish, huh? I think most of you finish, huh? Ling, finish or not?
Yes, sir.
Finish lah, huh? Okay, huh? Okay, now come back here now. Okay, actually, lesson 4, what you have learned tonight was actually refraction. Okay, now before I let you go lah, huh? I want you to tell me now, what is the meaning of refraction? Refraction is what? You Tong, what is refraction now? Use your own understanding what to answer lah. What is the meaning of refraction?
The change in direction.
Yes. Change in direction due to what? It will change direction because due to the change in the speed, correct not? When the speed changes, it will change direction. This is called refraction. Okay, so you have learned that how refraction. And also remember, under refraction, frequency will never change, but the lambda will change. The direction will change. The speed will change. Okay, and after that, you have learned so many diagrams. You have drawn the diagram also, right? The diagram show the refraction of water wave. You only learn tonight, you learn is a refraction of water wave. Okay, now I want to test you for last one. When the water move from deep to shallow, how the refraction happen? It will refract to which direction? From deep to shallow. Ziliang? Lim Ziliang.
Yes, sir.
From deep water to shallow water, how the refraction to which direction? Deep water to shallow water. You have the answer on the diagram. I asked you to jot down one just now.
Sorry, sir. I cannot hear your voice.
Okay, I repeat again. From deep water to shallow water. So how the water refract to which direction?
So the direction means
towards normal or away from normal. That's it.
Oh,
so which
okay.
one?
From
deep water to shallow water.
From deep
to shallow.
From deep is away from the normal line.
From deep water to shallow
and
water.
Then, for shallow is towards the.
Yeah, okay. It should be like this lah. From deep water go into shallow water, it should be refracted towards the normal. Whereas from shallow water go to deep water, right? It will refracted away from the normal. Understand? Juling, do you understand?
Yes, sir.
Juling, can you repeat the last one from shallow to deep, deep to shallow? How?
Deep to shallow is reflect towards normal.
Okay, correct. From shallow to
Then
deep?
Shallow to deep is reflect away from normal.
Yes, very good. Okay lah. Okay, everyone, please remember. Okay, if those who are not so clear about this, so please go and watch the video again, understand the diagram, and then learn how to draw the diagram. Okay, that's it for tonight. Okay, thank you very much, everybody. Okay,
Thank you.
I see you next week. Okay, bye-bye. Bye-bye.
Thank you, sir.
Yes, bye-bye. Bye-bye, everyone. Bye-bye. Okay, bye-bye.
Thank you, sir.
Yes, bye-bye. Okay. Yeah, bye-bye.